Hello, everybody. I'm Tanay. I'm going to talk a little bit about GraphQL with Data Federation. I'm the CEO co-founder at Hustler, an open source GraphQL engine that connects to multiple databases to provide an instant GraphQL API with built-in authorization, stuff like that. So a lot of the talk that I'm going to talk about today is based off some of the recent work that we're starting to think about and work with along with our users. So when we talk about federation in the GraphQL context, right, we've heard about this a lot, but what do we mean just to kind of set a little bit of context, right? We typically have multiple services and each of these services is owned by a different team. We want them to kind of be decentralized in its ownership, right? But we then also want a unified GraphQL API across all of them, right? So when we think about this idea of putting this together, right? Let's quickly take a pause and think about why should we even have this federation piece, right? Should we have a unified API? These different domains have probably been different for a reason, right? Do our API consumers want or need a unified API? Will they drastically benefit from it? Or is it okay for them to actually just have multiple APIs, right? For example, if you look at AWS's different services like EC2 and S3, right? The control plane APIs, right? The EC2 management API, the S3 management API. Now, would it make sense to kind of combine that together into one API? Are they that related? Or is it okay for them to be different APIs, right? And also, of course, when we're kind of thinking about all of this, what is the cost of kind of unifying this GraphQL API, right? Because suddenly now these multiple independent services now have a centralized coordination point, right? So there is a cost that both in terms of teams, process, and communication, but also in terms of like the operational aspect of like unifying that system that was unified, right? So there are, of course, very good signs when you probably want a unified GraphQL API. And if we think about kind of a few reasons there, right? The first would be a unified application experience. Your team is, or your organization is looking at one application that is largely powered by, and it's largely meant for users to have kind of a seamless unified experience, which probably needs to have a unified API, right? The API that we're kind of exposing is across services that have entities that have lots of relationships between them, and those entities might have a related life cycle. For example, if we look at, on GitHub, we'd have maybe say projects and issues and members, right, and PRs. There's not only deep relationships between these various entities, but their life cycles also are also kind of intertwined, right? The way each of these life cycles of these entities exist, right? If you think about authorization, very often that's also a good kind of use case for wanting to have a unified place where you can manage all of these various entities coming together. For example, you have a common viewer context that will have certain scopes or roles along with access control at an entity level, right? And you probably want to manage that centrally, right? So these are probably some good signs for needing a unified GraphQL API. So if you kind of step back and think about this, right, the unified GraphQL API probably represents a domain, which is a collection of related subdomains rather than a collection of independent domains, right? Again, this might seem obvious, right? But as always, these things are subtle in practice, right? Where we want them to be kind of more related so that it's a collection of related subdomains rather than a bunch of independent domains that are so independent that unifying them is probably going to be less useful than beneficial, right? So when we think about, we kind of double click on that, right? Why do we even have multiple subdomains if everything is so related together, right? Like authorization is the same application experience. Why do we even have multiple subdomains? Two of kind of common reasons are that each of those subdomains represent types of data workloads that have their own kind of logic. For example, you might have a payment system that has a transactional data store, transactional logic, right? You might have the users doing activities and emitting events that might be a more time series kind of piece of information that is processed quite differently, right? And then, of course, you might have a recommendation system in your application that is powered by an analytical piece, right? Which again has asynchronous logic and a different kind of data store entirely, right? And because you have these different subdomains that are functionally a little bit different, they are also very probably operationally quite different, right? Where they require different kinds of operational expertise to even run, right? So that, for example, is a fairly common use case for having like multiple subdomains that then are kind of representing a common domain, right? In this context, if you think about the nature of being service oriented versus data oriented, and again, I'm not drawing very clear boundaries here, but just to kind of frame or have different lenses or perspectives for looking at the problem, microservices are intended to be as independent in their ownership as possible, right? The business ownership of particular microservices is as independent as possible. So when we kind of think about unifying that capability, right, for especially a unified application experience, maybe we're thinking more about a backend for front end rather than a GraphQL API that is getting unified automatically by the microservices, right? We're probably thinking of an application that needs a unified API, and hence that ownership and the way that API is kind of constructed is going to be a little bit different if that rather than that API coming from the back, right? And so so that's kind of a subtle difference. There's overlaps, but there might be subtle difference in the way that we approach that problem, right? If we think about this from a data point of view, right, we have pieces of data and logic, right? And we want the piece of data and logic to be owned by different teams. It's squads for sure. And we want that to be decentralized. But we do want all of that to come together into one common application. Now, the fact that these pieces of data and logic that belong to a common domain, right, they don't have to be GraphQL, they can be anything, right? But the way that they come together, that one application, one API is what is where we kind of desire the GraphQL piece, right? So the way that kind of the GraphQL API is communicating with the subdomains, that could be anything, right? That could be kind of optimized in its interface to speak to those subdomains and the data and logic inside each of those subdomains, right? Three interesting pieces of reading material that might be useful for you folks is one, the post on Viaduct by the Airbnb folks talking about moving from this kind of idea of federating GraphQL from a service-oriented, from a service mesh to a data-oriented service mesh, right? From moving from a SOA to a DOA type system, right? Then, of course, is the idea behind the data mesh itself, especially if you're looking at increasingly data-driven APIs, and that's also a really good read to think about, what should be centralized, what should be decentralized, what should be federated. And then, of course, the third piece for us on the application side is to think about that BFF versus GraphQL or BFF and GraphQL, right? To think about how to best frame that problem. So given kind of that approach, right, let's talk a little bit about, instead of kind of federating across GraphQL services and joining them together, what if we think about GraphQL, but on federated data sources, right? And what's kind of the difference there? The first is that when we think about the decentralized subdomain teams, what we want them to do is we want these teams to be able to own their own data sources. That's critical because it's a, maybe it's a different kind of workload. It has a different kind of associated logic, right? And how they kind of expose that need not really be a GraphQL service, right? That could be anything, and that's totally fine. Because they don't need to be kind of burdened with the concepts of GraphQL, because that's not relevant to them. What's really relevant to them is just their data, the way they kind of manage their data, and the way they kind of handle logic on that data, right? Whether synchronous or asynchronous, whether it's integrating with other systems, right? Whatever that is. The central team, right? There's kind of a different team or a different set of individuals, right? That kind of brings together these multiple subdomains, right? And puts that together in a GraphQL API. So the GraphQL API is explicitly owned by a set of individuals or a central team that is bringing these things together, so that we're kind of getting the benefit because of this unified GraphQL API, because this central team can now solve those three problems that we talked about, right? They can try to solve the problem of a unified app experience. They can solve the problem of understanding how the entities across these subdomains are kind of interrelated, right? How their life cycles are related, what the semantic relationships between them are. And of course, the central team, in case of that unified centralized authorization concept, can start to think about what they would like their unified authorization system to look like. For example, if this team is exposing an API for being used externally versus an API that is being used to power an application, right? The way we kind of handle the authorization and security of that centrally becomes much easier for the central team to do, right? Because they're kind of owning that experience instead of having to push that down into the subdomain teams, right? Who are actually just owning data and logic. So creating that difference allowing our subdomain kind of teams or squads to own that data plus logic combination, right? However it's exposed, and the central team to really kind of own the GraphQL API is a theme that kind of emerges when we start thinking about GraphQL on federated data rather than federating to GraphQL services, right? And we talk about some of the kind of advantages of this kind of approach, right? And in this case, obviously, because the GraphQL API is being kind of managed or constructed or configured by the central team, they are kind of the team that understands how these things are interrelated, and they kind of connect these decentralized domains, right? Another interesting thing that this can result in is when we think about the method of kind of the execution of that GraphQL API, right, of our GraphQL query, right? This, in the way that we kind of technically build this system together, the GraphQL server can actually have the best kind of abstraction in the way that it would speak to one of these data sources or to the backing logic, right? So what you're kind of able to do is skip a layer, right? So you're not having kind of a GraphQL kind of service that's speaking to another GraphQL service that belongs to a subdomain that then speaks again to kind of, let's say, data sources or logic, right? You're able to kind of collapse that and say, well, I have this GraphQL piece and it'll speak in the best possible way to the underlying subdomain, right? To the underlying data, to the underlying logic, right? And that becomes a way that becomes easy to start thinking about, performance considerations, because what you can start to do is you can ensure that your GraphQL performance considerations are now centrally managed, right? And you're exposing your data and logic pieces in a standard way, right? And we'll take a look at what that looks like. So one of the biggest things here that we can talk about is this impact that it will have on performance, right? So and so when we kind of think about skipping that layer, right, and how that kind of adds performance, what happens in a typical GraphQL server is when we're speaking with even if it's a single GraphQL server speaking to a single data source, right? There's several kinds of optimization that are required to make that GraphQL processing efficient, right? For example, you typically want to integrate the authorization piece of your work with the data fetch, right? You don't want to fetch the data, then apply your authorization rule, right? You typically want to apply the authorization rule as you're fetching the data, because the authorization rule is a property of the data, right? If you're saying that, I want to fetch the last 10 orders that belong to me, you're probably making a query to the data system to say, I would like to fetch those orders that belong to this user, right? Within that data fetch call, you probably don't want to make a query to say, fetch all of the orders on the planet and then filter that for that particular user, right? So this is kind of a predicate push down, where you're pushing this predicate, the authorization predicate, into the query itself. You also typically want to either batch or reduce the number of requests that you're making to that underlying data source, right? So we're seeing that this authorization context and the data fetching are closely related, right, in the GraphQL service. When you split that out, right, that you have a GraphQL service that's kind of doing the unification, right, that's speaking to another GraphQL service that is doing the execution. The challenge there is that this information is kind of lost, right, because the authorization piece you might want to manage centrally, and this now sucks because you don't actually understand how to speak to the data system, because that information is present in the underlying GraphQL service, right? So there's a loss of information that prevents that fundamental kind of authorization, and you need to kind of do a lot more wiring up to pass that context, right? And in fact, doing that will probably result in a certain kind of collapse or a standardization of the interfaces. Another common problem is that when we're thinking about the kind of feature that we want to provide on the underlying system, we will lose information because if our subdomain is exposing a GraphQL service to our gateway that is becoming a GraphQL API, we are probably going to lose information about how systems are listed or paginated or filtered, because when we're kind of thinking about unifying these services, the only thing we're thinking about is mapping IDs together. So we're literally kind of taking an API call from service 1 and API call from service 2, and we're saying, yep, there's a ID here that goes into an ID there, right? And so that's all this GraphQL gateway kind of knows, right? Even though those underlying services are GraphQL services. So this gateway can't really do anything interesting as soon as you start running into use cases where you're not joining across objects, but an object has a nested list, right? Now that suddenly becomes, that's something that you need to think about very differently. And we'll take a look at an example of what that looks like. So that's kind of, as soon as we start getting into slightly advanced use cases, the problems that we'll start kind of facing, right? And a lot of customization that we'll have to start doing. So let's take an example where I always take a music database as an example. Let's say you have a simple kind of a query where you have artists, and each artist has multiple albums. And we have an artist subdomain and we have an album subdomain, and they're kind of different subdomains, right? It's coming from a different source altogether. Now, when we think about executing this query, like you would know, if I had different GraphQL services, a GraphQL service for artists and a GraphQL service for albums, what I would want to do is first I'd run a query to fetch all of the artists, right? And then for each of those artists, I'd run a query to fetch those albums, right? And obviously, what you want to do is make sure that the query that is being made to the album system is batched, right? So we're kind of batching, but we're not batching at the data source level, like the data loader. We're batching at the GraphQL level. So that information has to be threaded carefully, right? Typically, what you'd want to do is ensure that even though the GraphQL gateway is making a batch request to the album service instead of doing n+1 queries, it's making one GraphQL query that has pieces of fetching these different albums. You'd want to make sure that that is optimized with, there's a data loader that's inside source2 that's kind of optimizing this. And, what this data loader would do, what the album service is doing, if it's a GraphQL service, what the service is doing is it's probably has something like a query that says, get albums where album.artistid in, right? It's kind of like this in query. And for each of the artists that are coming in, each GraphQL query in the batch that's kind of coming into this albums GraphQL service is adding, each of those artists to that in array, right? That in clause of your data fetch. So you're saying, I have artist 1, artist 2, artist 3, artist 4. So let's get those albums where the album.artistid happens to be in one of those systems, right? And then you have to carefully wire that up into the right objects and then send that up. So of course, it's totally possible to solve, but we just have to make sure that the way that our GraphQL query is being batched from the GraphQL gateway, that is then being sent to the GraphQL service, and the data loader inside our albums GraphQL service is all kind of wiring things up well together, right? If we take just before I head to that, for those of you who've kind of implemented this system with something like an Apollo Federation to GraphQL, right? What you would notice is that the way that you would build the application, the way that you would kind of build this federation specification, right, is very different if you were connecting an object entity, and it's quite different if you're connecting a list entity, right? So the way that you would implement an album.artist and the way that you would implement an artist.albums, where each artist is multiple albums, is actually a little bit different. You have multiple kind of options, right? You're forced to kind of take one option. For example, in the albums case, you're forced to extend the type in a different way than you would extend if it was an object, right? But that's just a nuance. That's something to be kind of aware of as you're thinking about the system. So that's kind of one nuance and problem that we want to make sure we stay ahead of, right? Another place where this problem kind of, but not a problem, but another place where, oops, let me just get my light back again. All right, cool. So another place where we notice this problem kind of being a little more, a little exacerbated, right, is when we think about top n queries, right? So let's say we're fetching an artist, right, or multiple artists. And for each of these artists, we want to fetch the top 10 albums, right? Sorted by something, sorted by name or rating or whatever it is, right? As soon as we do that, and again, we're kind of thinking about this from a federating GraphQL services and not kind of federating on data directly. Once we fetch the artist or even a single artist, right, and you want to fetch the albums for that artist, right, you'd realize that the data loader and the batching optimization now becomes very tedious, because if it's multiple artists and you want to fetch the albums for those artists, right, you can't do the inquiry anymore. Because if you try to do the inquiry, you're not going to be able to do the top N, because the top is per artist. So it's the top albums per artist, right? So that's not a straightforward query to make in a single data fetch, right? And that becomes problematic, because now the way that you would construct this query is you require kind of deep information about that underlying data system, right? So that piece of context again becomes a little bit hard to thread from a gateway to a GraphQL service to a data system, right? And this is kind of a like this version where this kind of pagination type issue becomes another piece of wiring and context that has to be shared across these two boundaries, right? The third is when we kind of think about advanced batching, right? If you look at this kind of query here, just switch on my pointer, we notice that we're kind of fetching an album, that album's artist, right? Music album authored by an artist. And then we're also fetching reviews by other artists. So when we fetch the review, we want to fetch the artist's name of this review. So constructed example, right? But we do notice that we're kind of making queries to the system, right? Where we're still making a query, this artist service, right? But it's different parts of the query. So now we kind of start to require, when we're seeing multiple requests that are being issued for artists, right? And we want to make sure that when we're batching it, that common context is still being passed from different parents to the artist resolver, so that we're able to dedupe and batch effectively, right? And now that again is a piece of context that needs to kind of be shared or passed in a common way from the gateway to those services, right? And across all of these three examples, while they're not hard to do, right? When we start thinking about this idea that we wanted to have federated GraphQL services, we realize that in lots of cases, there'll be a tremendous amount of context that we're going to have to share between the GraphQL service as a gateway, but then also each of those individual GraphQL services, right? There's a lot of back and forth with each of the teams. And so you kind of realize that, well, the benefit of having each of those teams being very independent in their work, right, is starting to reduce, right? So that's kind of what you want to think about. If we take a slightly different approach to this, right, let's say we take a data federation approach, and that's kind of one of the things that we've been working on at Hasura, especially with our 2.0 release, right? And so let's see how we kind of, what another way to think about this would be, right? So if I have if I have this kind of system where I have a GraphQL API, in this case, say Hasura, which is powering their GraphQL API, what Hasura does is allows kind of connects directly to those data sources, right? And says, in this source, I have artists, which is a model, and Hasura understands that source deeply. So let's say it's a particular type of database or a particular type of data source. And then you connect to another data source, which has the album service, and Hasura kind of brings that model in, right? And that again is maybe a different type of data source, a different kind of database, say, that Hasura is kind of connecting to. So Hasura is kind of this understanding of, well, these are the two models, and this is the kind of underlying system that they're working with, right? So there's kind of this abstraction, this common abstraction in the way that it's speaking to these data systems, and Hasura understands those data systems deeply, right? When we now think about the relationships across these systems, right? Now we kind of think about saying that we think about model level relationships, right? So we say that, well, there's an artist model. It has an albums field, and the albums field is using this ID mapping, right, between those two models. And maybe album has an artist, right, which is not a nested list, but album.artist is going to be one object. And that again has the same kind of field mapping, right, the other way around. And so we kind of specify those two pieces of configuration, right? So we specified the models, and then we specified the relationships across those models, right? And then whenever we kind of compose a GraphQL query, because those two underlying systems don't care about GraphQL, right? Whether they're exposing data or they're exposing APIs for logic, whatever it is, those underlying subdomains, the artist and the albums domain, they don't care about the GraphQL aspect of it, right? They're just exposing models. The central GraphQL system is kind of really bringing that together and understanding how these relationships are done. And so now when we kind of create a GraphQL query, Hasura is able to kind of do a lot of the automation that is required to run that GraphQL query. When we benchmark these approaches, and this will kind of come out in our release later this month. I'm not sure because it's recorded. So later this month, we'll the difference that we see in performance is massive, right? If you're federating across GraphQL services and you're just running this query where you're fetching 10 entities and a list of their entities, we'll get about 5 RPS on this 4-core 8-gig machine, right? Where I just had Node.js running just out of the box. I would get 5 RPS, whereas with this data federation approach, I'd get about 200 RPS, right? And the P99s are at a completely different kind of by orders of magnitude, right? Which because this centralized system can do a lot of optimization in the way that it's doing the batching and the data loading, because it understands those two data systems deeply, right? The kind of capabilities that we would get by being able to create a central system that can understand underlying systems and having specific interfaces in the way that it understands those systems, and whether you're using Hasura or building your own system, you would have a data load that's kind of out of the box, batching that's out of the box. You'd be able to reference lists or objects without any differences in the way that you build those systems. And of course, within those kind of federated lists or objects, right, you would automatically get pagination and sorting and filtering according to a common convention that you can then have, right? So you can create a convention for pagination, sorting, and filtering that can automatically be enforced, right? It's not something that those GraphQL authors kind of have to worry about, right? That entire concern can be handled at the GraphQL gateway level, right? Let's take a quick look at a demo to see what this looks like. So I've set this project up here. And if I take a quick look at my data system, so this is a Hasura project that I set up here. This is going to be my GraphQL endpoint. I've connected in 2 different data sources here. So I have a data source that's exposing the artist's model. And then I have an entirely different database and a different data source that's exposing the album model, right? So the album, you can see, has an artist ID, right? And similar to kind of the configuration that I had in the slides before. So let's now go and try to run this API. So I'm going to go in here and say query artists, right, ID and name, right? And so we're kind of getting this data from our first data source, right? Let me just compress this so that we can see what's happening, right? And now what we do is let's, just fetch the first 10 so that it's easier to look at what's happening. And now we'll go and fetch their albums, right? Right. And now we're kind of fetching each system and its albums, right? And this is just powered by the same kind of configuration automatically, right? The nice thing here is that I can start paginating them, right? So I can say limit 1, right? So let's run that query, right? And I can also sort it within that. So I'd want to sort it by title, but let's sort in descending order, right? So we should notice that this value changes, right? And all of this is kind of powered just by a single piece of configuration that provides that ID mapping, right? All of our other capabilities around being able to join things, join lists, join objects, paginating, sorting, filtering is all kind of taken care of out of the box with insanely high performance, right? All right, so that's kind of a quick look at what data federation would look like. Of course, that is kind of the end of my time. But of course, if you'd like to chat more, discuss some ideas, brainstorm, please do feel free to reach out to me at Tamago on Twitter. Looking forward to kind of hearing from you and chatting more about this. And if you have some time for Q&A, then we'll chat more as well. Thanks, folks.